Hi students, welcome to myclass.com graph data structure. In this video, we are discussing the basic concepts and terminologies of graph data structure. So what is graph? A graph can be defined as a group of vertices and edges that are used to connect these vertices. Just like trees, there are vertices also there and the edges also there. But the thing is that not like a parent-child relationship. A graph can be seen as a cyclic tree where the vertices maintain any complex relationship among them instead of having parent-child relationship. When we are seeing a tree, this is the parent of these two children. The relationship is like that. But no, in a graph, there are vertices and edges, but the relationship is not a parent-child relationship, like a complex relationship. There is a connection with 0 to 1, 0 to 4. There is a connection with 3 through 1. Like that, this graph looks like. Let's assume that in an airport, this is a place named 0 and there is a airway connections, that is through airways we can connect it to this city and this all cities like this. You can travel to city 4 through this way and through this way. Like this also connected flight, we can also reach the city 4. In such situations, we are using graph data structure. So in graph data structure, we are called as vertex or vertices. So in this particular graph, this is a graph G with V is the set of vertices and E is the set of edges. So in this graph, V is 0, 1, 2, 3 and 4. Mainly the edges is the connection, that is if there is a path or connection between the vertices, then we can call it as this is one of the edge, E1, E2, E3, E4, E5, E6 and E7. So this is the set of, so E1 is the up to E7. So this is the set of edges. So we can define a graph as a graph G can be defined as the ordered set G, V, E, where V of G represent the set of vertices and E of G represent the set of edges which are used to connect these vertices. So this is the basic definition of a graph. Clear? So when we are considering a tree, so this is a tree, is it? So this is a tree. We can't find a cycle through, so we can't go to this from this node to this node in a particular way. That is not possible. But for a graph, it is possible. That is the main difference between tree and graph. There are mainly two types of graph, directed and undirected graph. In an undirected graph, edges are not associated with the directions with them. In an undirected graph, there is no arrow sign in this graph structure, in this graph image, because if there is a connection between 0 to 1, but 0 is not the starting point or the ending point, or 1 is also not the starting point and ending point, there should be a connection between 0 and 1. That is the undirected graph. So we can see the ordered pair of edges are like that: 0, 1, 1, 2, 1, 3, 2, 3, 3, 4 and 4, 0. There is also an edge between 1 and 4. In an undirected graph, the 1, 4, the ordered pair 1, 4 edge is also 4, 1. Both are representing the same edge. Okay. In an undirected graph, because there is no direction present in the edges. So what is directed graph? In a directed graph, edges from an ordered pair, edges represent a specific path from some vertex A to another vertex B. So like that, if there is an edge between A and B, there should be a correct direction of this edge. So this arrow indicates that A is the starting point and B is the end point. Okay, so the A is the initial and B is the terminal vertex. Okay, so that is the concept of directed graph. If there is a connection between B and A, then you can do like this. Okay. This arrow means there is an edge between A from A to B, and this arrow means there is an edge from B to A. Okay. Next is some graph terminologies, basic terminologies we are discussing here. So in this, first we already discussed what is vertex. Vertex is this each point that hold the value. This each nodes we can call it as a vertex or all vertices. And also this is called our edge. If there is a connection between two vertices, though we can call it as a edge. In an undirected graph there is no arrow sign, but in a directed graph there should be arrow sign in edge. Another terminology is a path. A path can be defined as the sequence of nodes that are followed in order to reach some terminal node V from the initial node U. Let's assume that in a directed graph, from A to E, if there is any path, is there any path between A to E? Yes. We can reach E through A, we can reach E through A, B, C, E. Is it? So A, B, C is a path between A and B. There is another path also A, B, E. Such ways are we can call it as a path. Okay, so what is closed path? Closed path, a path will be called as closed path if the initial node is same as the terminal node. Let's assume that the arrow is like this. Okay, note here, arrow is like this. So we can travel from B to B through this path. B, C, E to B. So this such path we can call it as a closed path. Okay, in this the terminal node and the initial node and the terminal nodes are same. Next is cycle. So what is cycle in a graph? A cycle can be defined as the path which has no repeated edges or vertices except the first and last vertices. We have already discussed a closed path. Just like that the cycle is also there. But in a cycle, it has no repeated edges or vertices. So let's assume that this is the arrow like this. So we can call it as a BCE. BCEB is a closed path, also a cycle, because no repetition of the edges and vertices except the initial node and the terminal node. See, let's assume that the arrow is like this, then we can travel like this: B, C, E, again B, then D, E, B. This is also a closed path: B, C, E, B, D, E, B. But this is not a cycle because lots of edges and vertices are repeated. B is repeated and E is also repeated, that is edges also repeated. But for this is the initial node and this is the terminal node. That is also possible in the case of cycle. Okay, so BCEB is a cycle and also a closed path. This is also a closed path but not a cycle. That is the difference between the closed path and the cycle. Then, what is connected graph? A graph G is said to be connected if there exists a path between every pair of vertices. There should be at least one edge for every vertex in a graph, so that we can say that it is connected to some other vertex at the other side of edge. See, in this example, this is a connected graph. If there is no edge between G and D, then we can't say that it is a connected graph. Okay, all the vertices are connected through any edges. Minimum one edge is there for all vertices. Okay, that is the connected graph. So what is complete graph? Complete graph is the one which every node is connected with all other nodes. A complete graph contains n into n minus 1 by 2 edges, where n is the number of nodes in a graph. Let's assume that this is the 3 nodes in a graph. So this node is connected to this is connected to this, and this node is connected to this node. So this is, we can say that this is a complete graph because the node 1 is connected to 2 and 3, node 2 is connected to 1 and 3, node 3 is connected to 1 and 2. So this is, we can say that it is a complete graph with 3 vertices. When we are considering 4 vertices, see, 1 is connected to 2, 4 and 3. Okay, then 2 is also connected to 1, 3, 4. 3 is connected to 2, 1, 4. 4 is also connected to 2, 1, 3. So this is, we can say that it is a complete graph with the 4 vertices. So the number of edges of a complete graph is, the equation is n into n minus 1 by 2. N into n minus 1 by 2. 3 into n minus 1, 2 by 2. So 3 is the answers are here. 3 edges are there. In this case, 4 into 4 minus 1, 3 by 2, 2. 2 into 3. 2 into 3 is 6. Here also 6 edges are there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 edges are there. So that this graphs we can say it as a complete graph. Next, loop. So what is a loop? An edge that is associated with the similar endpoints can be called as a loop. So here this is the loop. There is a edge between 5 and 5. That is 5 is connected to 5 itself. Such connections or such edges we can call it as a loop. Then what is adjacent node? Adjacent node means in this case of 3. 3 is connected to 1 vertex, 4 vertex and 2. There is a direct connection between 1, 4 and 2. There should be an edges to 1 between 1, 4 and 2. So this set of vertices we can call it as an adjacent nodes. So the degree of this node is called degree of 3 is 3. The number of adjacent nodes we can call it as a degree of that node. So well, let's consider 0. Is there any adjacent vertices for 0? No, there is no connection between other vertices. So we can call it as a 0 is an isolated node or isolated vertex with 0 degree. So in this graph is we can't say it as it is a connected graph because one node is not connected to other nodes. So we can't say it as a connected graph. So that is the graph terminologies. That is the basic concept of graph and graph terminologies. We'll see with the graph representation video in the next class. Thank you.